The electric potential energy of a system is the sum of the work done moving all of the charges in an ensemble in from infinity to whatever the desired final configuration might be. And we're going to assume that U equals 0 at R equals infinity. And the specific numerical example that we're going to do here, in order to make this a little quicker, is we're going to look at an example of 3-point charges of 1 microcoulomb, and we're going to arrange them on the corners of an equilateral triangle with sides 1 meter long. And then we're going to solve that through the process of superposition. So we bring in the first charge, and since it's alone in the universe, we get that one for free, and its potential energy is going to be equal to 0. The second charge will see the potential of the first charge, and the third charge will see both of the other charges. So let's take a quick look at this thing and look at how this goes. As we said, for the first charge, it's alone in the universe, and there are no other fields. So for that first charge, V is going to equal to 0, and therefore U is going to be equal to 0. So we get the first charge free. Then the second charge is going to see the potential due to the first charge. So the potential due to the first charge at the location of the second charge is going to be equal to 1 over 4 pi epsilon naught, 1 microcoulomb, 1 times 10 to the minus 6 coulombs, divided by a distance of 1 meter, which is going to make that 9 times 10 to the third volts. And therefore, the potential energy of the first two charges is simply going to be QV, or 1 times 10 to the minus 6 times 9,000, or 9 times 10 to the minus 3 joules. Now, when we bring in the third charge, it's going to see the V due to 1 and the V due to 2. All these distances are 1 meter. So in this case, although not generally, the magnitudes are going to be the same. So it's going to give us 2 times 9,000 volts, which is going to be 18,000 volts. Roughly the potential difference across the gap in your spark plugs. And the potential energy for 1,3 plus 2,3 is going to be equal to Q, 1 times 10 to the minus 6 coulombs, times V, 18,000, or 1.8 times 10 to the minus 2 joules, and so the total energy for our system is going to be 1.8 times 10 to the minus 2 plus 9 times 10 to the minus 3, which is going to be 2.7 times 10 to the minus 2 joules. We could do this with any number of charges in any geometry, although we would have to calculate the individual potentials in order to make this process work.